Hello everybody. Today we are going to look at how to balance the redox reactions using oxidation number method. The basic property of oxidation number method. What is the basic principle of oxidation number method? It operates on the basic principle of increase in oxidation number. Increase in oxidation number is equal to decrease in oxidation number. I am going to take an example to illustrate how to go about the balancing of oxidation number method. I am taking this example. This example is about the net ionic equation of potassium dichromate 6 with the sodium sulfate in acidic solution to give chromium 3 ions and sulfate ion. All of them are important. So I am going to take dichromate 6. It is going to oxidize sulfite into sulfate and you are going to get the chromium 3 ion, and the medium is acid. So let us first write the basic skeletal ionic equation. So Cr2O7 2 minus aqueous and SO3 2 minus aqueous gives Cr3 plus aqueous plus SO4 2 minus aqueous. Before you start doing with anything, what we can do is we can basically first balance the elements other than oxygen and hydrogen. So here there is no hydrogen I included. Later we introduce that. Basically now I am going to balance the other elements, basically chromium and sulfur. Sulfur is already balanced, both the sides you have only one sulfur, but chromium is not, so I just add 2 here. So let me add 2 here. Okay, I'll use this color, 2 chromium 3 plus. Okay, so let me take a little darker color, 2 chromium 3 plus. Now next step, what I have to do is I have to identify the change in oxidation number. So first identify the oxidation numbers. Here chromate ion, so for chromate ion Cr2O7 2 minus, if I want to find the oxidation number of chromium, so 2 times X plus 7 times negative 2, which is equal to negative 2, because oxygen is having an oxidation number of negative 2. So 2x minus 14 equal to negative 2. So 2x is equal to positive 12. X is equal to positive 6. So here you are having positive 6. And this is a simple ion, so positive 3. When I consider sulfite again I am calculating using the same method. X, because I want to know sulfur's oxidation state, 3 times negative 2 is equal to negative 2. X minus 6 is equal to negative 2. X is equal to positive 4. So positive 4. And if I do the same thing here, it will get positive 6. So now I will be able to identify which undergoes increase in oxidation number, which undergoes decrease in oxidation number. So when I consider positive 6 to positive 3, this is decrease in oxidation number. Decrease in oxidation number, and positive 4 to positive 6, increase in oxidation number. By how much? What is the decrease? What is the increase? 3 per atom, because every chromium atom is getting decrease in oxidation number of 3. So, but there are 2, so 3 multiplied by 2, which is equal to 6. And when I consider sulfur, it is increased by 2, only 1 sulfur is getting, so 2 into 1. So the next step, what I am going to do is I am going to equate the increase in oxidation number and the decrease in oxidation number, because that is the basic principle on which this method works. So decrease in oxidation number is 3 times 2, increase in oxidation number is 2 times 1. So when I want to equate, actually this is 6 and this is 2. So when I want to equate, I multiply the increase side by 3 so that it becomes equal. So when I multiply by 3, now the equation is going to change. How it is going to change? I am going to multiply the increase side. Increase side means I am going to only multiply the sulfur part, not the chromium part. So Cr2O7 2 minus aqueous plus SO3 2 minus aqueous gives 2 Cr3 plus aqueous plus SO4 2 minus aqueous. Now if I multiply by, let us say here 3, then this side also 3, so that the sulfur is balanced also. The next step in this method is we need to actually balance the charges. When I balance the charges, if it is an acidic medium, I can only add hydrogen plus ions as and when required and where it is required, whether the left hand side or the right hand side of the equation. If it is a basic medium, I can only add OH minus ions. So this is happening in the acidic medium. That's what we have seen in the problem. So now let me first balance the charges. I am just taking left hand side and right hand side. When I look at the charges, negative 2 plus 3 times negative 2. Here 2 times positive 3 plus 3 times negative 2. I want to equate these charges. So here the left hand side net charge is negative 2, negative 8. In the right hand side the net charge is positive 6, negative 6, so 0. So either I can make the left hand side 0, otherwise I have to make the right hand side negative 8. As I told you, it is an acidic medium, so we can only add a positive charge, that is hydrogen plus. So if I add on the right hand side, it becomes positive 8, it doesn't equal the left hand side. At the same time, if I add positive 8 to the left hand side, then it becomes 0, so the charge on both the sides becomes 0, it is equal. So to balance the charge, I am going to add 8H plus on left hand side. So let me write again the equation. So Cr2O7 2 minus aqueous plus 3SO3 2 minus aqueous plus 8H plus aqueous gives 2Cr3 plus aqueous plus 3SO4 2 minus aqueous. Now what is missing is hydrogen is not balanced. So always to make hydrogen balanced, you need to add appropriate number of water molecules. I am having hydrogen plus or hydrogen in the left hand side of the equation. So to balance, I need to add water molecules on the right hand side. Every water molecule has 2 hydrogens. So I need 8 hydrogen. Totally I am going to add 4 water molecules on the right hand side. So again I rewrite the equation. Cr2O7 2 minus aqueous plus 3SO3 2 minus aqueous plus 8H plus aqueous gives 2Cr3 plus aqueous plus 3SO4 2 minus aqueous plus 4H2O liquid. If you verify whether oxygen is balanced or not, it will be balanced. If you look at on the left hand side, 7 plus 9, 16 oxygen. So here 12 plus 4, 16 oxygen on the right hand side. So oxygen is automatically balanced. Here you got the balanced ionic redox equation for the given question. So what did I do? I wrote the skeletal equation, then I balanced the elements other than oxygen and hydrogen, then I found the oxidation numbers of the elements which are undergoing change in oxidation state, then I equated the oxidation numbers. Once I equated the oxidation numbers on left hand side and right hand side, then I balanced the charges using the clue, that is the medium. If it is acidic medium, I can add only hydrogen plus. If it is basic medium, I can add only OH minus. Then after balancing the charges, I added appropriately on a required side the number of water molecules which balance the hydrogen. So I got the final equation balanced. So I don't need to separately balance oxygen. So this gives you a smooth go on balancing redox equations using oxidation number method. You may try one question. I am just giving one question which you can try using the steps, using the video as your guidance, and you can use. I am just going to give you a basic medium. So you can try that using the guidelines given in this video. If you get a correct equation, I'll be happy. We'll see whether you understood or not. Try this. This is the skeleton I'm giving. That is the basic ionic equation. So this equation happens in basic medium. Try to solve. Try to get the balanced chemical equation. This is to try. This is the balanced equation. This is the balanced equation which I was started with. Thank you for watching.